Hey, it's Mr. Saltano. This lesson is going to be on scientific notation. So first of all, scientific notation, what is it? It's a shorter way to write numbers essentially. So it's a nice condensed way to write relatively long numbers. So for example, this is an actual number that we use in chemistry fairly often, and it's a huge number. Imagine having to write all of those zeros over and over again. But we also use this if it's a very small number. So for example, this number is very tiny. A number like 0.0000, etc., 324. So this is a nice condensed way to write that number. So at the very least, it's a shorter way to write these numbers, and it looks a lot more neat, essentially, when you write these without including all of those zeros. So there are a couple different forms that I want you to be aware of. The first one is called the standard form. That's just how you would normally see the numbers the way that we were just looking at them. This is the standard form. The scientific notation form is the new one we're looking at. Now if you look how much more neat this number is than the number to the left of it. Same thing with this large number down here compared to the number to the left of it. It's a much neater way to approach this and to write it, and it's easier to work with essentially. A couple new words for terminology. The first is the coefficient. That's where this red underline is. This part of the number before the multiplier sign is the coefficient. This is going to be very important coming up. This power of 10 over here is the exponent. So we're going to be using these terms to describe what to do, so you want to make sure you know the difference between them. Coefficient, exponent. So the rules for how to write this. If our exponent is negative, so let's say we're trying to convert this scientific notation number to standard form. If our exponent is negative, then that means our number is going to start with 0. It means our number is going to be very small, in fact, if the exponent is negative. And in fact, here we go. Here's our number that's starting with 0. It's a very small number, right? It's because it's a negative exponent. If our exponent is positive, then that means our number is going to be greater than 1. So here we have our exponent's positive. Our number is typically a large number, but it's at least greater than 1. And so that's what we're looking at here. Now, how do you do it? So get ready. This is going to be almost like an episode of Sesame Street a little bit here. The first thing you do is you find the decimal. Now, obviously, not all numbers are going to include the decimal right away. You just have to assume where it is. And so for this number of 5,000, we would know, obviously, that the decimal point can be found at the end of the number. The second step is to move that decimal so that the number you form is between 1 and 9 to the left of that decimal. So, in other words, we want to move this decimal over here so that this number at the end can be between 1 and 9. So if I moved it to right here, this spot, that would give us 50. That would not be between 1 and 9. If we moved it here, though, we would get a number between 1 and 9, which is 5, because we moved the decimal. Now, the other important thing is you want to count the steps as you do this. So, how many steps? 1, 2 steps, 3 steps, 3 steps. So we moved it 3 steps, and we moved the decimal to that spot. And then we know we went 3 steps. And so this is what our scientific notation number becomes. It becomes the new number that we made once we moved the decimal, which became 5, times 10 to the third power, because we moved 3 steps. So that's how we know that. Now our original number is greater than 1, so therefore it makes sense that our exponent is actually positive. So far we did this correctly. Now, if we try to convert this to scientific notation, our decimal will be moved. In order to make this number between 1 and 9, we follow the same rules. So are we going to go to the right or to the left? We're going to go to the right, actually. And again, we're going to count the steps. So how many steps is that going to take to get over so that our number is between 1 and 9? Well, it's going to be 1, 2, 3, 4, 5 steps. So it took us 5 steps. So see if you can predict what our new number will be based on that. We move the decimal. We went 5 steps. And so our number becomes 4 times 10 to the 5th power. Did our original number start with 0? It did. So that means that our exponent has to be negative. So again, if you have a very large number, you're going to have a positive exponent. If you have a very small number, you're going to have a negative exponent because our number started with 0. Now, this is a very important point. A negative exponent is not a charge. It's got absolutely nothing to do with charge. It's just completely positioning. It's telling you exactly the position of this decimal. So a negative exponent means that that decimal is going to be for a very, very small number, a number starting with 0. But the number itself is actually going to be positive, so that's an important point. This coefficient here is positive, and this number in standard form is positive. It's just it's literally the address of the decimal is what it's telling us. The other important thing I want to bring up is I don't want people in our class saying move to the left or move to the right, because that changes. So don't think a negative or positive sign means left or right for the decimal, because that's going to confuse you. Just remember that a positive a positive exponent means a large number greater than 1, and that a negative exponent means a number that starts with 0. Don't do left and right, because if you convert one or the other, the directions change. Go from standard to scientific notation, the left and right changes compared to if you go from scientific notation to standard. You're going to confuse yourself. Okay, so here's our first example. Try to test yourself and see if you can make a number with scientific notation for this standard form. So you should have gotten this. Notice we moved one position, and we made our number between 1 and 9, and our number was greater than 1, so that means that our exponent is positive. So this exponent is 1 because we move one step, and positive. What about this one? Well, we moved our decimal across actually 1, 2, 3, 4, 5 spaces, and our original number is greater than 1, so our exponent is positive. So 8.515 times 10 to the positive 5. And we keep as many of the non-zero digits as we can. What about this one? See if you can figure this one out. So this one is going to move the decimal 1, 2, 3 spots, but our original number is a very small number. It starts with a 0, so therefore we have a negative exponent. That's where that negative exponent comes in. Again, very important. If you don't put the negative in, the answer is just wrong. And it's the address of the decimal there. What about this one? So this would be, again, we started with 0, so we're going to have a very small number, but we move the decimal one place, and therefore it's 9.781 times 10 to the negative 1. Again, we start with 0, so we have a negative exponent, we moved it one space. So that's what you would have gotten for this. Now we're converting actually from scientific notation to standard notation. We're going the other way. And we have a positive exponent, so we know our number is going to finish being greater than 1. And we know we're going to move it 4 places. So when we do that, this is the answer that we get. Now, what do you think of this one? This one's actually a little bit tricky. A lot of people would say you get 0 for this, but actually 10 to the 0, or anything to the 0 power, is going to be 1. And therefore your answer is going to be 8.96, just 8.96, because you're multiplying it by 1. So just a side note, anything to the 0 power is a 1, so this is what we get. Now, something else is very important. This is a different skill that's a little bit tricky to learn. Is this number shown here in scientific notation? So think for a minute, what are the rules that apply to these numbers, and does this number count? So it's close, right? But it's not quite there because it's not between 1 and 9. And so this is the real answer. This is what the answer is supposed to be if you're in proper scientific notation. You have to be in proper notation to get this right. And the reason, again, is because it's not between 1 and 9, and now this one actually is between 1 and 9 for the coefficient, right? Coefficient must be between 1 and 9. Now the way that you do this actually is, if you need to, in order to make your number between 1 and 9, if you need to make this number smaller, this coefficient smaller to do it, then the exponent goes up, is the rule. So for example, we had to go from 54.5 to 5.45. Our number got smaller for our coefficient, and therefore our exponent got bigger. They do the opposites. The other very important thing is not only does it get bigger in this case, but it also gets bigger by how many steps that you moved. So for example, we went one space over, we got one space smaller on the coefficient, and then so our exponent got one space bigger. So again, they do the opposite of each other. Now what if we have the opposite example? So see if you can probably start to figure out how the rules apply for this one. In this case, in order to make our coefficient between 1 and 9, we have to move our decimal to make our number larger. So what do you think will happen to our exponent? Well, our exponent will then get smaller, right? And then it'll get smaller by however many steps we moved. So in this case, we moved 2 steps. So our exponent should get smaller by 2 steps. And in fact, it does. And the no is because this number is not in proper scientific notation, but this is in proper scientific notation now. Our coefficient got larger, and so our exponent got smaller by 2 steps. Okay, and that's just kind of reminding you. Okay, so what do you think of this number? What would you do? Well, in this case, it would be, we moved 1 space, and our coefficient went down by 1, so our exponent went up by 1. In this case, we are going to move to make our coefficient smaller by 2 spaces, so our exponent gets larger by 2 spaces. And then in this case, our coefficient is actually going to get larger by 3 spaces, and so be careful with the -4. This is actually going to become a -7. Because our coefficient got larger by 3 spaces, so our -4 gets smaller by 3 spaces. But to go from a -4, 3, and then move 3 smaller, that's actually going to give you a -7. So this is tricky. And that's all we have here for scientific notation. Thanks for watching. And remember, chemistry is everywhere.